Okay, for heap overflow, we're going to use a heap overflow. This is again using Douglas malloc. So we're going to see that layout and we're going to get the flag. So if we look here in the folder, we have this traditional set group ID executable. Let's take a look at the code again. So again, they've provided us a win method, which is very convenient. We don't have to include our own shell code. Let's see. So there's a malloc of 666 bytes, followed by 2 mallocs of size 66. We get to know the address of that full one, and we're going to get to overflow that first one, or that second one, really the third one if we want. Then we're going to free the first one, and then we will free the second one, and the third one we exit. But what we're going to try to do here is we're going to try to get our exploit on this very first free and overwrite the got entry for putS. That way we don't have to worry about trying to keep the data structures consistent quite as long. So we're going to work on this first free. And so what we've seen before in Douglas malloc is this unlink method. And so the unlink method will give us the ability to change things based on these forward and backward pointers. Now, in order for that unlink method to happen, we have to have 3 chunks in a row. We're going to try to remove something. So what we'll do here is we're going to deceive Douglas malloc. We're going to be freeing this very first thing, but we're going to confuse it so that it believes the second one is also free and it wants to consolidate those. Okay. So let's take a look at this slide here. We have our first one. The size of that is 672 bytes. And the reason for that is because we have a malloc of size 666. We have to add 4 for that extra header information. And we round up to the nearest multiple of 8. So that gets us 672. The second chunk, we want to perceive that the second chunk is going to get collapsed in. So we need the third chunk to think that the second chunk is free. And so we tell the second chunk its size is -4, which is a little bit weird. One of the nice things about that is we don't have to worry about any null bytes. When we overflow into the second chunk, we're not going to have to write any null bytes. And that can be hard with a string copy, for example. So when we say the second chunk has size -4, the third chunk will just be sitting just to its left. So the third chunk, its size will be here. We don't really care what its size is as long as it's even, which means that the third chunk will tell us that the second chunk is free. And when the third chunk tells us the second chunk is free, it will then try to consolidate the first and second chunks. And so we will unlink that second chunk. When we unlink that second chunk, we'll process these forward and backward pointers. So these forward and backward pointers in the second chunk, which is getting removed, we're going to set to fp -12. So that fp is the function pointer. So this will be the got entry for putS -12. And the address needs to be pointing to the beginning of the shellcode. So it'll be 8 bytes in to our buffer. Okay, so let's take a look at our Python. So we're going to open up the vulnerable executable. The command line argument doesn't matter, it's just left over. I read the memory address, and then I read the prompt. I'm going to send in shellcode where I'm just filling, these are dummies, these don't matter, these forward and backward, so I just put some A's there. Then I need to push the address of win and return. That'll be my shellcode. Push the address of win and return. Now the shellcode gets put in plus 664 minus the length of the shellcode. So that gets us to the beginning of the next block. So the beginning of the next block, because we start not at the header, so to get to the next block, we just need 664 minus the length of the shellcode. Then we're going to put in this 4Bs. 4Bs is an even number. So if we look at our ASCII table, right, capital B is 66. So that gives me a nice even number. Then we're going to need our -4. So -4 in 32-bit 2's complement is FC, FF, 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 because it's in little endian order. Then we're going to put in the address of the God entry for put s -12, and the address of the buffer +8, which will push us right here to our shellcode. We then send that. We need to send the last name. We'll go into interactive mode, and we should get our flag. Okay, so there's our flag, a simple heap. So again, the key thing that we did here was we overflowed the first chunk, we overwrote the second chunk, and we made this really a third chunk. So the reason we overlapped the third chunk on top of the second chunk is so we didn't have to worry about null bytes. So we just did this negative size. It also helps us if our overflow can't be very long. So we have our first chunk. Our second chunk has a size of -4, which says our third chunk begins here. It tells us our second chunk is free, which means we can try to consolidate this. So we'll perform that unlink method to pull out the second chunk. When we do that unlink here, that will set the God entry to put s to point to our shellcode. And also, as before, 8 bytes into our shellcode will get overwritten, but our shellcode is less than 8 bytes. And so just like before, that unlink method overwrites a God entry and gets us the flag.